Cones, cylinders, and spheres. Having gone through a considerable period of time doing ellipses, we are now ready to launch into the next few Platonic solid forms. This is the lonely cone. However, a lot of things depend on cones, not the least of which is ice cream. The cylinder, which is important in so many ways, modern plumbing would be nowhere without it. And the sphere. Now we're going to look at a number of drawings that are based on these shapes and or combinations of these shapes. Going forward here, I'll show you rather brief schematics of the raw form of the drawing that comes afterwards. So, in this case, here are a couple of cylinders. And as a representative form, here are a couple of empty bullet shells. Growing up in rural Michigan, I was very familiar with bullets. These are 30-06 shells. Stretching further afield, here's an example of a number of combined cylindrical forms. That are the composition for this, a deep-sea exploration vehicle. Note that the cylindrical forms here are combined with spherical forms for the front of the sub's nose and both the fore and aft parts of the propulsion arms. Cylindrical and semi-spherical forms are extremely strong forms and able to withstand extreme atmospheric pressures in deep sea environments. This is a rather odd-shaped schematic for the basis for this fanciful early science fiction submarine, the Nautilus from Jules Verne's 20,000 Leagues Under the Sea. While not official as the Verne version, this is the version popularized by Disney in 1954. This is a prime example of what is now highly revered as steampunk, the combination of 19th century technology with that of the modern world. These are two conical shaped schematics, here finalized as artillery shells. Conical shapes are very often used in rockets, missiles, and projectiles because of their aerodynamics. This schematic represents something much more pedestrian in nature. The common kitchen funnel. Conical shapes also work very well for directing both dry and liquid substances from an area of large opening to a more precise opening. This rather odd schematic is one that nature creates. It is a type of seashell known as an auger. An additional related type is known as a rostelier. Again, designers of submarines obviously recognize the strength inherent in the type of cylindrical and conical shapes employed by the nature when they set about creating underwater architecture. This schematic represents another kind of craft that relies on being able to slip through the air to the same extent that subs slip through the water. An early jet fighter plane. The conical-shaped fuselage created less wind drag and thus allows the plane to achieve very high speed and maneuverability. And this schematic should be familiar to anyone who enjoys the 4th of July. It's that of a rocket. This particular example is a sketch of a German V-2 rocket from the latter part of World War II. What became an instrument of destruction actually became the basis for our early NASA program. The V-2 was the grandfather of the Saturn rockets, which ultimately took humans to the moon. Going much further afield now, here are some schematics and drawings for several science fiction spacecraft. In the past, I had to draw a bunch of these for a flash animation project that I was working on. These are but a few of several dozen that I did. But you needn't feel that you have to stray far to find examples to draw from. This schematic represents a humble baseball. This schematic is something that everyone relies on daily, a common incandescent light bulb. And this strange combination of shapes is actually the basis for a dome shelter, a shape popularized by F. Buckminster Fuller.